So if you're a C++ developer, you already know the language has gone through this massive transformation, right? But here's a question. Are you just using the new syntax, or are you really, truly thinking in modern C++? That's what we're going to dig into today, the mindset shift you need to master the language as it is right now.
I mean, listen to the man himself, Bjarne Stroustrup. When the creator of the language says C++11 feels like a new language, he is not kidding around. This wasn't just some minor update. No, this was a fundamental reinvention of how we actually write C++.
And that really gets to the heart of it. It's one thing to know about auto or lambdas or move semantics. It's a whole other ballgame to know when to use them, how to use them the right way, and importantly, why they're better than the old way of doing things. That's the real challenge, effectiveness.
So how in the world do you bridge that gap between just knowing about the features and actually mastering them? Well, what you need is a guide. You need a map that can show you the path to writing code that isn't just modern, but is also correct, efficient, and, something you can actually maintain.
And for literally millions of C++ developers, that guide is Scott Meyers' legendary book, Effective Modern C++. For years, his whole Effective C++ series was the gold standard, and this book just picks up that torch and carries it right into the modern era.
And hey, you don't have to take my word for it. Herb Sutter, the chair of the C++ Standards Committee, calls it the most important how-to book on the subject. I mean, when the guy in charge of how the language evolves tells you to read something, you probably should listen.
And then you've got Andrei Alexandrescu, who wrote Modern C++ Design, calling it a towering achievement. Look, this isn't just empty praise. It's a huge flashing sign that this book has absolutely essential knowledge for any serious C++ developer.
Okay, but that's enough talk about the book. Let's actually see its principles in action. We're going to jump right into the very first item in the book and explore one of the most fundamental concepts in all of modern C++, type deduction.
Seriously, understanding type deduction is like learning to see the code matrix. It's this hidden logic that the compiler is using all the time, for templates, for auto, you name it. And once you understand these rules, you can predict exactly what the compiler is going to do. And it all starts with template type deduction. Now, this isn't some new feature, but it's the bedrock that all the new stuff like auto is built on. If you get this part, you're most of the way there.
What the book does so brilliantly is it just simplifies this whole complex topic down to 3 cases. That's it. All you have to ask is, what's the form of my parameter? Is it a reference or a pointer? Is it a universal reference? Or is it just a plain old value?
Okay, let's start with case 1. This is where your parameter is a reference or a pointer. The logic here is simple. The caller already gave you the reference, so the compiler just has to figure out the type inside. Notice here with Rx, the expression's own reference is ignored, but its constness, that's preserved. So t becomes const int.
Now for the magic trick. Case 2, the universal reference. Here's how it works. If you pass it an lvalue, and you can just think of that as something with a name like our variable x, the compiler keeps that lvalue-ness by making t a reference type. But if you pass it an rvalue, like a temporary number, 27, t gets deduced as just a plain type. This little distinction is the secret sauce behind perfect forwarding.
And finally, we have the simplest case of all, pass by value. Think about it. Because you're creating a completely new, independent copy, the compiler just strips away all the extra stuff from the original expression. References, const, whatever. A const int end just becomes a plain int, clean and simple.
Okay, deep breath. We've just mastered the 3 rules for templates. So you might be thinking, great, but why does that old template stuff matter? Well, here is the big payoff. Every single thing you just learned applies directly to auto.
And this slide, this is the whole secret right here. Auto type deduction is template type deduction. The compiler basically pretends it's looking at a template. The keyword auto, that's just t. And the way you declare the variable, like const auto and, that's just our param type. It's the same logic, just in a different costume.
So the most important thing to get is that you don't have to learn a new set of rules. All that work we just did with the 3 cases, it applies one-to-one. The same rules for references, for const, and even for those weird edge cases like how an array can decay into a pointer, it all just works.
Let's just prove it to ourselves. Look at auto x equals 27. That's a copy, just like our pass by value template, so that's case 3. Now look at const auto and. It's a reference, so it matches case 1. And auto and being passed an lvalue, that's our special universal reference. Case 2. See? It's the exact same pattern every single time. Learn it once, use it everywhere. So,
Why on earth did we go through all of that? Well, because understanding the compiler's logic is what separates guessing from knowing. It's the key to writing predictable, solid modern C++ code. It lets you use these incredibly powerful features with confidence.
And one of the most fantastic things about this book is that every single item ends with this, a things to remember section. It just boils everything down. It reminds us that for type deduction, references are ignored, that universal references have that special lvalue behavior. Pass by value makes a clean copy, and arrays can decay. No ambiguity, just the rules.
And this all leaves us with one final thought for you. We've just seen how a really fundamental concept works under the hood. It kind of makes you wonder, what other habits, what other assumptions from the old C++ 98 days might be holding you back from writing truly effective modern C++? And that, right there, is the journey this book sets you on.